triangles are congruent, what do I know about their angles and sides then? Yeah, if two triangles are congruent, their corresponding angles and their corresponding sides are all congruent, right? Why didn't I mark B and E, by the way? Why don't I have to? It's implied 180 degrees. Anybody remember that theorem? Third angles theorem. Yep. Look at all this review we're doing. So yeah, if two triangles are congruent, the corresponding sides and angles are congruent. Not the case for similar. All right. So what's the deal? If two triangles are similar, first, did I go over the similar symbol on Friday with you? No, anybody know? Because you got congruent, right? We know that symbol down pat. Anybody know the similar symbol? Camilla, what do you have? Oh boy, that's the last time I hear that word in here. Yes, it is the little squiggly called tilde. Tilde, everybody. Tilde. If you want to call it squiggly on your own, go ahead. But in this class here, tilde. All right, so I'm going to call this triangle ABC, and I'll call the bigger one DEF. All right, so here's the deal. If I know two triangles are similar, the angles are still congruent. Okay, corresponding angles will still be congruent. The change is going to be in the sides. Okay? Two triangles are similar, corresponding angles are congruent. The sides are not equal, but they will be proportional. What do I mean by that? Ready? Let's call AB 2 and ED 6. Let's call AC 3 and DF 9, BC 4, EF 12. What do I mean by the sides are in proportional? Here's what I mean. All right, here you go, 11. What's the 2 match up with in the other triangle? Okay, 2 over 6 is the same as, what's the 3 match up with? 9. And what's the 4 match up with? Does everyone see they're all in the same ratio? That's what you know about similar triangles and their sides. They're in the same ratio. And while we're on that topic, that ratio we're going to call is the scale factor or the similarity ratio. So you look at two sides, what's the ratio? That's what I'm looking for, scale factor, similarity. So what would it be for this one? What's my similarity ratio or scale factor for these two similar triangles? 1/3. Could you also put 4/12? Yeah, you could. It doesn't bother me if it's not reduced or not. So it'd be 1/3 for this one. You guys remember, of course, you've written a ton of these. This triangle is congruent to this triangle. Well, I can do it for similar too. All right, so triangle ABC. All joking aside, your brain and your hand are just brainwashed right now to write what next? Congruent. Watch yourself. Watch yourself. Similar. And yes, the sides and the angles still need to be in the same order. Corresponding order. Triangle ABC, similar to triangle DEF. Okay? Questions from you guys. If two triangles are similar, what the deal is. And then again, scale factor, similarity ratio, that's the ratio of their sides are in. You told me how many methods of proving triangles congruent? Okay, here we go, midterm review. Give me one of those methods. It's 24, one of those methods. All right, I got an additional follow-up because we're 1 week away from the midterm. Where's the angle have to be? In between. On fire, I like it. We're ready. Somebody's hungry. 1, give me another method. Where's the side got to be? Okay, here we go. This was painful first period, so let me do this. There are your two congruent angles. Where's the side have to be? BC or AC, not in between. Everybody good? Next up. Here we go, 15. Give me another method. Where's the side have to be? Done. Another method. 14. Whoa, boss. But I got to be using what type of triangle in the proof? Right triangle. What's the H stand for? L? Good. And the missing one, which I'm proud of you guys. Nobody said right off the bat. 14. There it is. There are your 5 methods. All good? Similar triangles? 3 methods. Only 3. Only 3. Wait till you see this first one. Pretty darn easy, the first one. Aa, angle, angle. So all that means is you need 2 pairs of angles and we're done. Let me say that again. You need 2 pairs of angles and we're done. They're similar. Look at my example here. I need to figure out why HOU is similar to SOE. What did I give you already? What did I give you already? H and S are congruent. They're already 45. They're congruent. Who, and at this point, you better be able to give me the second pair. Where are the second pair of angles located? 5. Angle SOE is congruent to UOH. Why is that? Good. Oh, it would fire me up if anybody put O congruent to O. Reflexive at this point in the year. And then let's write me a good statement now. Because now I'm done. Everyone see I have 2 pairs of angles? That's good enough. They're similar. So write the statement for me. 6.
Triangle HOU is similar to triangle SOE because of AAA.
By angle, angle. I know I have the tilde in the notes, but you don't have to put the tilde with the AA. Whoa, check your work. Anybody put congruent right now? Self-respect. How many put congruent there? Angle, angle, all good? Next one. Side, ooh, this looks familiar, huh? Side angle, side, but it doesn't mean the same side angle side for us from congruent. The angle still has to be congruent and in between, but the sides now have to be in the same ratio. All right, sides have to be in the same ratio. So first of all, where's my angle here on these 2 triangles in my example? A is congruent to D because those are all right angles congruent. Yep. Now you have to show me that the sides around it are in the same ratio. Okay? All right, here we go. 24. Give me a side in triangle ABC. 8. What's the 8 match up with in triangle EDF? So I have to check. I need to check, does 8 over 6, is that in the same ratio as, what's the other side left? 4 over 3. I got to make sure those are the same ratios. All seriousness, how do you check if they are? How do you check if those are the same? There's really 3 ways you could do it. You could simplify everything and see if they come out to be equal. That's one way. Another way, Naomi, I could find out the decimal in your calculator. 8 over 6, is that the same decimal as 4 over 3? Anybody know the other method? You could cross multiply. Anybody ever know that? If you cross multiply and they come out to be equal, they're the same ratios. So what do I end up with here? Are they the same? Yep. So does everyone see how side angle side works? So now give me a good statement right now. 9. Triangle. Anybody put the congruent sign? What? Okay, change it. Okay, ready? By what method? Okay. I didn't have you put it on angle, angle. It wasn't needed, but the tilde does have to go here. Anybody know why? And not because I'm trying to make life difficult on you. Aaron, why? Yeah, because side. If you just write side, angle, side, what are we assuming you did to the triangles? You proved them congruent. All right, that's why I need the tilde there that says, oh, I proved them similar. All good. Angle, angle, side, side. And another method that looks familiar, side, side, side. So what do I have to know about all three pairs of sides? They're in the same ratio. Now, the most difficult part about this one that everybody has is matching up the sides. How do I know what side matches up with what? All right, well, let's talk. Because you're going to have to come up with three ratios and see if they're all equal. Like I yell out 13. What's 13 match up with? You're I don't know. Make it easy on yourself. And this is going to seem crazy when I say it. Smallest side with smallest side. Largest side with largest side, right? The smallest side should match up with the smallest side in the other triangle. All right, so I need somebody to write three ratios for me that we're going to test. 13. Here you go. Pick a side. 5/10. Is that in the same ratio as keep rocking? 8/16. Same ratio as? Darn right. How do you check that one? I could reduce or find that I probably wouldn't cross multiply because you would have to do every single combination of two ratios. All right, but you could. Are those all the same? Yeah, they all reduce down to what? A half, and a half. Yep, they're good. So give me the similarity statement now. 24 similarity statement on fire today. Match them up. Come on, Violet. You're better than this. Come on. Oh, got her. Got her. Got her. It's all right. I was waiting for somebody to do that. Similar to? I don't know. I'm just writing it down. How's that look, kids? Looks good? No, it's all right. I'll keep writing it down. By? Do you think I need the tilde here? Yeah, there's a side, side, side for congruent. Yep. All right. There you go. Everyone all right? Those three methods. Angle, angle, side, 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 side. Because now you're going to have to decide, one, if they're similar, and two, what method now. Ready to go. Number one, are they similar? If so, what's my method? I don't want an answer here. I got a couple questions for you. 19, what's already been given? 19 here, 19. Okay, what's already been given? Okay, so there's only one method it could possibly be because I did not label any of the side lengths. So it's got to be angle, angle, or nothing here. Is there anything you can mark on your own? There you go. Because they're what type of angles? They're verts. And what method do I have here now? What's this method? Angle, angle. I'm done. That's what's so great about angle, angle in proofs. All I need is a two pair and I'm done. All right, so what's the statement now? Ooh, 21. What's the statement? Triangle. Oh, got him! But got the big boss back there. What do you got now, Dylan, huh? Where are you at now? That's what I thought. Get on my level. I'm ruined. I was waiting. I was hoping he was just gonna ruin him. Go ahead. See, he's rattled now. Similar to? Oh boy. He's just gonna give me. What do you have? Is that right? AX. Yeah, that's good. You good? Got him. Got him. The stud back there. His kryptonite. Everyone all good? Okay, look at 2. Stop with the excuses. All right, stop with the excuses. All right, number 2 here. It could only be 2 possible methods. What are the 2 possible methods I'm going to try to check here? 2 possible methods. 8, what are my 2 possible choices here? Yep. Who answered that one? Hi, Izzy. How are you? You choose which one you want to test. Okay, side angle, side. So I already have the right angles. So I'm going to ask somebody to see if the sides around them are in the same ratio. So can you please set up that ratio you want us to test? It's got to be the sides around the right angle. 10, what are the sides you want me to test?
12 over 9 equals
Nope.
16 over
So 12, okay, hold on. Just, this is something, set it up. He's setting it up a little differently than I have. I always go side with the corresponding side. He's doing both sides in the triangle, which is fine. All right, there's multiple ways to set it up. So what's the 12 correspond with?
No, I'm doing 12 from the bigger.
Oh, all right, never mind. Go ahead.
And the second one is 16 over 4.
Okay. Regardless on how you set it up, you should be cross multiplying 12 and 12 and 16 and 9, regardless on how you set it up. All good? I don't know. Does this work? Is this a good ratio? Yep. So give me the statement now. 9, give me a good statement.
Triangle PMX is similar.
Dylan, you hear that? Yep.
L, nope, W, L, A.
Thank you. By what method, John?
Side angle, side similarity.
Good. How are we feeling here? Good? And then how about number 3? What's the only method it could possibly be? There's only one method it could possibly be. If it was, what's the 24? What's the only method? It could only be side angle side because I have the vertical angles. All right, so let's test the sides around. Could somebody came up with a ratio, 2 ratios for me to see if they're equal? 17, 2 ratios.
4 over 3 and 8 over 4.
Are those the same? Same ratios? Nope. So pretty easy one here. Not similar. All good? Questions? All right, ready to set up your own ratios and solve now. Set up your own numbers and solve. Top 5 word problem for me this year. Top 5. Natasha. Let's just say she got a little free time on her hands. A little too much free time. I don't know where she goes, probably the local park. She places a mirror on the ground. That's 24 feet away from an oak tree. That's important that it's oak. She's going to walk backwards until she can see the top of the tree in the middle of that mirror. She stops, and she notices her eyes are 5.5 feet above the ground, and she's 4 feet from the mirror. Using all that great info, how high is the tree? As we laugh at this, I could see some of you guys doing this, having just that right amount of free time to go to the park and set up your mirror, try to set it up and get after it. All right, so we have formed 2 triangles. We have formed 2 triangles. So now the question is, can I set up a correct proportion to solve? Matching up the correct corresponding sides. $19. You think you could set one up for me? Take any side first. 4 over. Is that, yep, equal to, yep, her height versus the oak tree height. Yep. Let you guys figure out how tall that big oak is. $12. How big's that big oak? 33. And I love what you did at the end there, which was what? Feet. We are in honors and doing a word problem, so from now on, and I'll keep reminding you, if it has units, you put units on your answer. 33 feet. All good. Because this is where I may lose some of you. All good? Next one, finding side x. Do we see two triangles in that diagram? All right, we always every year I have issues with a triangle within a triangle problems. Okay? And coming up with the correct proportion to solve. So first thing I need from somebody is, in the small triangle, can you please give me a side? In the small triangle. Here we go, 12, yep. 15, thank you, we'll take 15. You can only match up full sides in the triangles. So when I ask, what does 15 match up with, 10's not going to cut it. 10 is not a full side in either triangle. Okay, so that's one sticking point there. The 15 does not match up with the 10. That's not a full side, but it does match up with what in the big triangle? 24, again. 25. Do we see that? And then the other side, you could use 12, but you're not going to be solving for x then. I got to use 17 and x. Everyone see that? You can only use full sides in these proportions. Oh, got a little decimal action, huh, kids? It's okay. Nobody panic. Don't start pounding your calculator again to see if it'll come out to be a whole number. It's okay. What was that one? 28.3 repeating in your calculator? Okay, can we clean that up a little? Because I hate writing 0.333 or the 3 with the little bar. I never understood that. 2 and 28 and a third. Everyone all right? Ooh, how about the next one? Do we see a triangle within a triangle? Okay, so let's set up a proportion based on their sides. Give me one side in the small triangle. 18. What do we have? Yeah. 3. Everyone good? It matches up with the 8. That's pretty easy. 4. Does not match up with x. X is not a full side. It does match up with this full side in the big triangle. So my question is, how do you express how long that is? Because I'm sure I'll get 2 different responses for this. I'll get 4x and I'll get 4 plus x. Which one is it? 4 plus x, yes. Got to add the sides together to get the whole side, not multiply them. Yep. And not right now, but soon after the midterm, you're going to set one of those up and probably have to factor, but not right now, so enjoy it. And another decimal, right? 6 and 0.6666 repeating. 6 2/3. We'll clean that one up. Okay. Everyone good there? I got one more to do. Anything you want to ask? Comfortable setting them up? You're on your own. Watch out for the triangle within a triangle. Okay, we'll end class here talking about perimeters now of 2 similar figures. All right, so here we go. I got 2 similar quadrilaterals, it looks like. Yep, 2 similar quadrilaterals. I'm given some side lengths, all side lengths of the larger one side length of the smaller one. What's the perimeter of the smaller one? But I don't want to do this. Hey, I don't want to find each side individually by setting up all these proportions. All right, I don't want to do that. All right, I want to get to it a little quicker. What does WX match up with in the big one? Use your statement if you don't know. Use the statement. What does WX match up with? MQ, everyone agree? WX and MQ. All right, so 4 matches up with 8. Everyone agree? The perimeters are in that same ratio, 4 to 8, 1/2. Okay, so whatever ratio the sides are in, the perimeters are in the same ratio. So why do I tell you that? What's the perimeter of the larger one? If you do 9 plus 10 plus 7 plus 8. Ends up being 34. Both perimeters are in a ratio of 1 to 2 as well. So I don't need to set up all these different proportions to find the missing sides. I can just say, the sides are in a ratio of 4 to 8, so are the perimeters. They're equal to the ratio of 4 to 8. And we get a perimeter of, what do we have? 17, no units, nope. All right, nice job. Start thinking about questions you want to bring to Wednesday's midterm session. Topics.